So this was just doing the right triangle, Pythagorean theorem. This is just multiplying both sides by 2. Multiply both sides by 2 to get rid of that 1/2. Okay? This is really just all multiply. You can just go kind of straight across in your calculator, as long as it's in degree mode, because you're feeding it degrees, right? Okay? Then here, you had to make the height there, and that splits it into 2 equal right triangles. But that makes that angle 15 degrees, and the base 5. And then, who's the chief? SOHCAHTOA. So I'm working with this degree measure, and I have the opposite, and I need the adjacent, so I use tangent. The tangent of 15 is equal to the opposite over the adjacent. Now you don't need to set all this up. I just cross-multiplied to show you. But you could just do 5 times 1, which is just 5, divided by the tangent of 15, and you would get 18.66. And you will be using those today. So it's coming back, right? Well, I'm refreshing your memory.
Yeah, it's still not fully there.
Yes, 18.66. Okay? Are you good with the warm-up? Let's keep going then. Definitions. So a circumscribed polygon is just a polygon drawn within the circle. My circle's not so great there, but the vertices hit the circle. Okay? So then the definition, the center is the same as if it was the center of the circle that was drawn around it. Make sense? The radius is from the center to any vertex of your polygon. Any vertex of your polygon. You should have this all written down. I took it straight out of the book. Same thing. The apothem, say it, apothem. Apothem. A, I put that in yellow. So here it says it's the distance from the center to any side. So it's not as long as the radius, correct? Because it only goes to the side of the polygon. It is the height to the base of the isosceles triangles formed by 2 radii. So I put that on my picture so you can see what it is. Yeah, it's from the center. It's the height to the base of the triangle formed by 2 radii. And then the central angle of the regular polygon is the angle formed by 2 radii to consecutive vertices of the polygon, which is nothing new. You've been working with central angle before. It's just considering it as in a polygon. Does that make sense to you? Yeah. Questions on the definitions before we move on? Okay. So in this particular section, there are actually 2 formulas. I'm going to tell you what they are. So the area of a regular polygon, the formula the book uses, I believe, is this one. Area equals 1/2 A, which is what? What's the A? Apothem times P. What do you think capital P stands for? Perimeter. Okay. This is the apothem. And capital P stands for the perimeter of the polygon. Now, there is another formula that can be used to find the area of a polygon. Sometimes I think it's confusing to have 2. You can do, please pay attention to this, you can do this whole section with this formula if that's the only one you want to remember. But sometimes it's more work, depending on what they give you. So the other formula is this. 1/2 r squared, the r stands for what? Times n. What does n stand for when we're talking about polygons? The number of sides. Yes. Times the sine of theta. And the sine of theta is the measure of the central angle. Now, we're going to do a little bit of both of these. Mostly we're going to work with this one, but we are going to use this one once. This is the number of sides.
What's the central angle?
Central angle, right here. The central angle of a regular polygon is the angle formed by two radii drawn to consecutive vertices. That means vertices that are next to each other. Okay? All right. Let's practice these. You can use this or this. If you only want to memorize that, that's fine. Sometimes it's a little more work to get what you need in there. Sometimes this one's easier, but it's up to you. In the diagram, RSTUVWXY is a regular octagon. That's important. How many sides in an octagon?
8.
Let's just write that there just in case we need it. Inscribed in circle C. Find each angle measure. Okay. If we need to find RCY, what would we do? How many sides are there?
8.
If you don't know and you don't want to screw up on the test, sometimes it's good just to number them. There's 8, right? If I need to know this angle measure, how would I find it? It's a regular octagon, so each of these are equal, aren't they? So 360 divided by 8. Yep, equals 45 degrees. Okay? Don't make it harder than it is. We're not really using the formula actually in this first question right here. The measure of RCZ, this is Z right here. I know it's not very legible. This is Z. So we're looking at this angle right here. If this is 45, then what would RCZ be? Half of it. It would be half of it. Half of 45, which equals 22.5 degrees. And then the measure of ZYC. So this angle right here, ZYC. How would we do that? Yeah, if we know that this is 22.5 degrees, then we can just subtract, right? 180 minus the 90-degree angle minus 22.5 degrees equals 67.5 degrees. Cool? Now that wasn't using any of that. That was just to get you thinking about the parts of a circle or a polygon. Okay? So now let's use some of the formulas on the back. All right. You are tiling a floor with ceramic regular hexagons with side lengths 8 inches. How many sides are in a regular hexagon?
6.
So just in case we need to know that, I'm just going to write that up there. What is the area that the tile will cover? Okay, so, you know, I always like to draw a picture. Hexagon looks something like that. If you need to, draw a picture. The side length is 8 inches. I'm going to draw the center and just kind of do this. Maybe it'll help me. I don't know. I'm going to see. Apothem. Apothem. So here, if I use this formula right here, area equals 1/2 A times P. I can get P, can't I? Yeah, by doing what? Yeah, 8 times 6. So let's start by doing that. First, let's find the perimeter. And we just do 8 times 6, which equals 48. Right? Okay, the other thing I need is A. So the second thing I'm going to do is find A. And what I'm going to do is I'm just going to take one of these triangles right here, and I'm just going to draw it like this so we can kind of get a visual. This is 8 inches, right? And I know that the apothem, or A, is the height. You see that? Okay, so then I also know something else in here. I know an angle measure. How do I know an angle measure in this piece that I took out of here? How do I know the central angle? Can I figure it out? Yeah, I can do 360 divided by what? This is angle B. Okay, the measure of angle B is equal to 360 divided by 6, equals 60 degrees. Right? Do you all understand why I did that? Why did I do that? Because if I know what angle B is, then I know that this is 30 degrees. Half of the central angle. Because I just took this piece right here. Right? Okay, how does that help me? Does that help me find A?
Yeah, so you know 2 angle numbers, then you can subtract.
Then I can use one of my SOHCAHTOAs to find A. Right? If I'm just looking at this triangle right here, I know that that's 30 degrees. This is 4, correct? And I can use tangent. So I'm going to say, all right, A is going to be equal to the tangent of 30, which is equal to my opposite 4 over A. Opposite over adjacent. And you can do this all in one calculation. You're just cross multiplying, correct? What is underneath here that we don't write? A 1. So we do 4 times 1 divided by the tangent of 30. Do you all see that? 4 times 1 divided by the tangent of 30. And when you do that, you get this. I'm not going to make you go through all that, but this is what you should get. 6.92. Yes? Did you get it? Okay. If you didn't do it, that's all right. So now we have A and we have P, don't we? So I can use this formula to get the area of the whole thing. Plug in what I know. The area is equal to 1/2 A, which is 48. Oh, excuse me. I'm flip-flopping these, but you know what I mean. It doesn't matter what order you write it in. I'll multiply. Okay, and then you just do the math, and you've got the area. So 24 times 6.92. What would my units be? Inches squared. Now, you may say, well, why didn't I use the other one? We could have. Probably would have been easier. Do we have N? Yeah. Do we have R here? No. Well, we could have found it. So either formula we would have had to do a little bit of work, so it didn't matter. Okay? All right, let's move on and do 3 more. I don't know, I'm not going to get this done, but I'll get as far as I can. Finish it tomorrow. Find the perimeter and the area of the regular polygon. So, let's look at this. Let's find the perimeter first. Let's count the sides. I don't know how many sides, but I need to know that. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 sides, right? In order to find the perimeter, I need to find MP. I need MP. All right. One thing I do know is that the measure of angle N is equal to what? The measure of angle N is equal to what? 360 divided by 10, which is 36 degrees. So I'm going to draw this triangle that they gave me. I'm just going to draw it down here. This is 8, this is 8. This is a right triangle. I know that this is angle N. That means that the piece inside here is how many degrees? 18 degrees. I need to know this piece right here, don't I? Can I do that? I can. Once I find that piece, I can double it to find the side length. So what SOHCAHTOA, what tangent ratio would you use to find that piece right there? You have the hypotenuse. and this is the opposite. So which one would it be? Sine. So I would say sine of 18 degrees equals the opposite, I don't know, over the hypotenuse, I do know. So then you're just going to cross multiply. This is really over 1, so you just have to do these two multiplied together to get x, which is approximately 2.47. But then I need MP to get the perimeter, so that's double that. That's double that, which would be about 4.94. So one side length of my decagon is 4.94. So how do I get the perimeter? So the perimeter is 4.94 times 10, which is equal to approximately 49.4 units. So there's the first part of that problem. See why it takes a long time? Okay, let's do the second part. Let's do the area. I'm going to use this formula right now. 1/2 r squared. So I have the radius, I know the number of sides, and I know the central angle, theta. I know the central angle. So I have all the pieces I need with that formula. The other formula, you need the apothem. We don't have that yet, so that'd be more work. So let's use what we know here. 1/2, what's the radius in this picture? 8 squared times the number of sides, which is what? 10, times the sine of my central angle, which we decided is how big? 36 degrees. Oh, we have everything I need here to get the area. So I can just plug that right into the calculator. See what you get when you do that math. What'd you get when you put it in there?
188.1 approximately.
Yeah, I just did this, but yeah, that's fine. Units squared. Okay? Oh, let's just do the perimeter just because, before you leave, of this one here. Okay, let's see. We're given the apothem and we're given the radius, so we could use either equation here. But first, we're going to find the perimeter. What do we need to do here to find the perimeter? Do we need a tangent ratio to find the perimeter? Because we just need to know this, so we just need to know x there, don't we? And then double it. So let's use a Pythagorean theorem. 6.5 squared plus x squared equals 8 squared. I'm just using the Pythagorean theorem on that right triangle. X is approximately 4.66. The side length then is double that. 2 times 4.66, which would equal 9.33. Side length is 9.33. How many sides do we have? 5. So perimeter is equal to 9.33 times 5, which is approximately going to be what? 46.64. Okay, we'll finish this tomorrow.